So so the evolution of the staircase are one of the oldest elements, building elements, architectural histories, reflecting the prevailing philosophies of symbolic language. No, sometimes the stairs are part of the uh, rituals of other buildings. No? We do not why we do not need staircase. We need staircase to protect people from injuries and to facilitate access during movement from one level to another building. So the stairs main function is to vertical transport for people to go up to the other floors. No, the location of the stairs should be placed at a central location in the building so as to give shortest access to all rooms. It should be well ventilated and airy. So the main reason why we put the stairs uh, near the centrally located because of the pedestrian pedestrian traffic, no? So we need to put it in the nearest location near to the entry to minimize, no, the traffic of people, no, wandering around the building. So that is why one reason why we put the staircase strategically uh, very near the main entrance or very near the main traffic of the building. So it should be well ventilated for the purposes of uh, uh, the building. The main stair should be free from molds, no. So if it's well ventilated, it will be free from molds, from moisture, no. So the ventilation also will help the people that go up the stairs to have enough air, no, to breathe, no, because of if people will go up and down the stairs, so definitely they will be exhausted, so they need the air, no, to breathe during the the process of climbing the stairs. So the width of the stairs for public building should be at least 1.8 meters and for residential at least 1 meter. So the flight of the stairs should be restricted to a maximum of 12 steps and a minimum of 3 steps. No? You should bear in mind also that in designing stairs, no, you should break the stairs, no, the flight of the stairs into upon reaching the 12th step, no. So you should break it, then create a landing, then create another flight of steps, no. So the 12 steps is a maximum, no, number of steps, no? And the pitch of the stairs, no, the slope should not exceed 400 and should not be less than 250. So the pitch, no, it means that the the angle of the flight should be uh, user friendly, no. If it's too steep, no, people may not climb it comfortably, so you need to make the steps or the flight of the stairs angle should be designed for people, no, that will that sometimes are disabled, no. So another one is the distance between the tread and the soffit of the flight immediately above it. It should not be less than 2.1 to 2.3. So this is the headroom with which the common person is about 7 feet, no, which is 2.1 meters. So there should be enough headroom, no, for people not to bump their head on the next flight or the beam above the flight of the stairs, no. So and materials should be constructed using fire-resisting materials. Materials also should have sufficient strength to resist any impact. So another consideration is the type of material to be used on stairs. No? So you need to make sure that the stair material is fire resistance and has a characteristic that can carry, moving loads, no. So because sometimes people run going up and going down the stairs, so the moving load that's being uh, directed to the stairs should be, the stairs should be designed, no, to carry that moving load. So the balustrade, all open well stairs should be provided with balustrades, no. Those are the what you call this, the vertical balusters, no, at the end of the flight of the stairs, no. In case of wide stairs, you should be provided with handrails on both sides. So if it's if the stairs is what you call this adjacent to a wall, no, you can put a handrail, no, instead of putting balusters. If it's wide enough, it's too wide, no, you can like the steps on LRTs or on steps on going up to a church, no, when you can see that the stairs are wide, no, you can put handrails, no, you put railings so that people will not fall down, no, when going down the stairs, or sleep, no, in case that they will sleep, they can hold on the handrails. So the landing of the stairs should not be less than the width of the stairs, no. I will show you some of the drawings later on. So the winders, these should be avoided and found necessary if may be provided at the lower end of the flight, no. So the winders are the stairs that are the steps that are cut into pizza pie shapes, no. So those are the winders, and these should be avoided and should be, in case that you need to put this type of winders, you should put it on the lower end of the flight, no. Another one is, no, this is the principles to be observed while planning and designing the stairs, no. Stair, it should be at least 1 meter, the width. The length of flight, the number of steps at single flight should be not less than more than 12. We have discussed it earlier. It should be, the pitch is about 25 to 40 degrees, no. Width of the landing should be at least 150 millimeter, no. So it's 1.5 meter. So that is the width of the landing. So winders or kite steps, odd-shaped steps should be avoided. To, in case found, they should be provided at the start of the stairs. So I have talked about the pizza pipe shape of the steps. So those are the winders. So you should put, if you need to put the winders, you should put it at the bottom part of the steps. Handrail should be at least 750 to 850 millimeter in height. So it's about 75 centimeter or 85 centimeters. Those are the handrails, no. So those standards, you should always follow those standards from 75 to 85 millimeters. That's the height of the handrail. Step proportions, the size and rise of the tread in the stair should be kept in uniform throughout the whole stair. So the size of the height of the riser and the size of the tread should be uniform, no, on all the steps, no. So the headroom, the minimum is 2 meters, no. So I said based on the slide before, it's about 2.1, but the minimum is about, you can like in the Philippines, no, Asians are not that tall, so the minimum height is about 2 meters, no. That's the headroom. So following the proportions, these are the recommended dimensions. The tread for residential is about 250 millimeter or 25 centimeter. The riser is about 16 centimeter. In public buildings, the tread is about 300 millimeter or at least 1 foot, and the riser is about 15 centimeter or 6 inches. So industrial buildings, the railway station, so the tread is not less than 250 millimeter for industrial buildings, and the riser is about not less than 150 millimeter or 150 to 190 millimeter or 19 centimeter. So these standards, you need to follow these standards in designing steps, no, steps or stairs, no, in your future projects. So these are the different parts of the stair, no. As you can see, we have the drawn are the different parts that you can observe while going up on the stairs, no. So as you can see, there is the newel, this is the landing, this is the what you call the balusters, this is the handrail, which is about the standard is about 85, no, centimeters the height. So this is the tread and this is the riser, no. This is the face of the riser and this is the tread, no. This is the newel post on the bottom and a newel post on the landing area. So, okay, so this is the tread. So the tread is the upper horizontal of a step upon which the foot is placed while ascending or descending. So this is the tread. This is the place. This is the part of the stair where you step on when going up or going down. So that is called the tread. Another one is the riser. It's the vertical portion of the step providing a support to the tread. So this is the riser. This is the riser. This is where you, this is the part of the stair, no, that should be observed properly. No, if you create a riser that is too high, the person that is going up will get exhausted easily. No, you need to make sure that the riser is about 6 inches, no, or 6 inches, or sometimes about more than 6 inches, about 8 inches, no, in height. No, that is the 6 to 8 inches. That is the riser, no, riser height. Another one is the flight and landing. No, this is the unbroken series of steps between landing. It's a level platform at the top of the or the bottom of a flight between the floors. The main reason for a landing is providing some rest for the climber. So this is the landing where you break the flight of the stairs, no, the steps. So giving the maximum number of 12 steps going up to the, and then you break it on a landing, then another 12 steps going up to the other landing. So that is the way you will design steps, no, or stairs. Another one is the rise and going. So this is the going is similar to the tread, no, but this is the common term when you what you call this, you design it and you you need to calculate the total length of the occupied tread, no. No, so this is what you call the G, or the going. So you can calculate because the tread might go up to the bottom part of the riser. So what is the clear, no, the clear opening of the tread, which is upon the bull nose of the tread and another bull nose of the tread. That is what you call the going. Okay, so because sometimes this is more deeper, no, this one, the tread is more deeper than the going. Okay, now we have the nosing and the soffit. What is the nosing and the soffit? The the nosing is the edge of the what you call this, the tread, no. This is the tread, and then we have different types of nosing to prevent the person going up to sleep, no, or to fall down, no. So sometimes you put nosing that are that has what you call these textures, no, or designs that will prevent the people to sleep on the nosing. So these are sometimes textured corner, so that the person that is going down will what you call this, the shoes will suddenly stop, no, because of the nosing texture, no, or the finishing of the nosing. Then we have the optional cove molding underneath the nosing. Then this is the riser, and this is the tread. So you need to in creating drawings or detailed drawings, you need to draw this and put dimensions of this what you call this detail, no. So if we will the next plate for this week, you are required to create a detail of this stair, nosing, riser, tread, no, complete with the detail, the dimension, and complete with the finishes that you will use for this component. Okay, so this is the string. So these are the sloping members which supports the steps in the stair, no. So this is the string. If you will go back, this one, this is the stair string. If we look at this, this is the stair string. So you put the tread here, then you put the riser here. Okay. So now we call this the newel post, no. Newel post is a vertical member which is placed at the end of the flight to connect the end of the string and hard rail, no. So this is the handrail, and then we put a newel post to make sure this handrail or the baluster are sturdy, no, or are doesn't move. So this newel post is the component of the stair that holds the balusters, no, or the handrail. So this is the balusters. No, as you can see, there is a newel post here, and this is the what you call this is the handrail, and these are the balusters. No, okay. So this is the bull nose, no, or the nosing, and this is the riser. No, as you can see in the detail. So the handrail, it is a rounded or molded memoir of wood or metal, following generally the contour of the nosing line and the fix on the top of the baluster. So this is the what you call the handrail. No? So as you can see, the balusters, you can put you can use other material in designing the balusters. You can use glass, you can use wood, you can use steel. You can use, sometimes you don't need a, what you call this, a balusters. You can attach the handrail on the wall, as you can see in the detail, in the picture. So now, this is the headroom. This is about, the minimum is about 2 meters, no? Some, in the Philippines, it can be about 1.8, no, in the Philippines. No? But it's a what you call this? It's a standard that you use a 2-meter headroom. So it is the minimum clear vertical distance between the tread and the overhead structure. This is the flight of the stairs, no. So the minimum at the measuring from the edge of or the nosing of the tread to the overhead of the structure, which is sometimes a beam, sometimes it's a slab. So that is what you call a headroom. So this is about approximately about 6 feet or 8 inches, or about 2 meters, no, or less than not less than 2 meters. Okay, so so this is in definition. This is are the different definitions of the different parts of the stairs, no. We have discussed this on the previous slides, but I need to post this on the PowerPoint so that in case that we have an examination, you can read the definitions. Okay? So these are the nosing. No? The scotia is the molding provided under the nosing. So this is the molding which is called the scotia. No? Okay. So another one, this is the step, no? The tread, the rise, and the going. No? Yeah, okay. And the flight, no? A series of steps without any platform, that is called the flight. This is the landing, which is the end of a flight. And then the run is a total length of the stairs in horizontal plane, including the landing. So this is the total run. No? So if you will calculate the total area that was occupied, including the what you call the platform, that is called the run. Okay? The headroom, no, we discussed the headroom, the slope, and the riser, the nosing, okay, the winders, no, and the string and the stringer. Okay, those are the balusters and the walking line. No? So the approximate line or of movement of people on a stair during ascending or descending is known as the walking line, and it is situated at a distance of 450 millimeters from the center of the handrail. So that is what you call the walking line. So that is the most frequent area of the stair that people walk into. So that is measured 450 millimeter from the handrail. So that's about 45 centimeter from the handrail. That is the walking line. So that is where the people always walk. Okay, so we have the different types of steps. No, we have the bull nose step, the round-ended step, the feeler, splayed step or the commode step, the dancing step or the balancing step, splayed step, and the winder. So this is we will define the different types of the steps. No, so the bull nose is generally provided at the bottom of the flight. No, so it's projecting in front of the newel post. Is the end near the newel post form and a quadrant circle. So that is the bull nose step. This is called the bull nose step, and this one is called the round-ended step. Okay, this is the round-ended step, and this is the bull nose step. So these are designs that you can incorporate in your stair, no, layout. You can put a bullnose, you can put a round-ended step, no. So these are common designs that you can see in old buildings, no, during the American period or the neoclassical era, that they put the round-ended step and the bullnose step. This one is the commode step, no, and this one is the dancing step. So you can see that you can what you call this? You can create, no, different designs on the stairs, no, by creating different configurations of steps, no. So another is the winder. So this is the winder, no. This is the winder, the pizza pie steps, no, that are being commonly seen on in case that you have what you call this, limited, no, limited area, no, so you need to put more steps to create winders, no. So this one is the splayed step, no, and like the bullnose or the rounded, no, there is a 45-degree what you call this, splayed, no, no. Another one, this one is the geometry of the stairs. No? Stair safety and geometry are related with rhythmic movement along the straight line. It is important for safe ascent or descent. So, as I've said before, no, you need to make sure that the riser and the going or the tread is always, you know, the same height or width in all of the steps of your stairs. No? So that is one basic principle in doing a stair design. No? You need to make sure that the height of the riser and the going width or the actual tread width and the pitch is all the same or uniform in all of the steps of the stairs. No? So you need also to observe the proper height of the riser and proper width, no, or length of the tread or the going, no. So the going or the tread, you need to observe it with a minimum width because people the size of the foot of the person going up or down may not fit, no, or may not step properly on the tread, no. If it's too small, no, the heel, no, or the toe of the person might not step, no, properly, no, on the going or the tread, no. So if it's too small, no, the heel of the person might fall or might not step accurately on the tread, no, or the material of the tread. So the headroom we have discussed is this is about 2 meters minimum or 6 feet 8 inches, or maybe you can make it about the maximum is about the ideal is about 2.1 meters, no? The ideal, but you can make it higher, no? There's no limitation on the height of the headroom. So the stair angle, as you can see, we have the 26 degrees or the 45 degrees or the 260 or the 450. So this is according to the fixed platform, walkway, stairways, and ladder design, construction, and installation guidelines. No, the stairway should be angled between 26 to 45 degrees. That's between 1:2 and 1:1. So as you can see, no, this is the you should observe, no, this stair angle so that the people that is going up or going down will not get exhausted, no? Okay, so the landing must be at least 30 inches, no, deep and 22 inches wide and every 12 feet of or less or vertical rise. Unprotected size of the landing must have a standard of 42 inches with guardrail system. So that is the end. The landing is what we put at the end of the flight of the stairs. The flight of the stairs is about a maximum of 12 steps. After reaching the 12 steps, you put a landing. So that is what you call the minimum, the landing must have at least 30 inches and 22 inches in dimension. Okay, so the platform swing windows, no? So this is the where the door or gates open directly on a stairway. Provide a platform that extends at least 20 inches beyond the swing of the door. So this is one basic principle in designing the platform or the landing at the end of the stair, no flight, no. If you have a flight of stairs, no, like this one, and there's a door at the end of the flight of the stairs or the landing, there should be a clear of 20 inches at the edge of the door when it is open, so that people will not fall down the landing or the platform when the door is open. So this is the 20 inches, what you call the swing door clearance. Okay, so this is a common mistake of architects and designer. If the swing door does not meet the 20 inches clearance, people might fall down when they open the door. Okay. So this is the other designs of stairs that has chairs for accessibility for PWDs. No, you can put a straight accessibility mechanism on a straight stair. You can put it on a curve or the spiral stair, and you can put it on a straight stair with flat slope landing. This is one with the landing, this one is the direct flight, and this one is the curve. So there are mechanisms that you can put on a stair that the disabled or PWDs can sit on, and then they can go up on the upper floor, no, using this stair chair. Okay. So these are the different types of stairs components. No, this is what you call a nosing. This is the you can these are commonly made of materials like section like steel and wood. No, so sometimes it's made of plastic. Now it's made of hard plastic. No. And sometimes it's made of steel, made of copper, you know, or sometimes made of aluminum. No? So this is the different types of. Now, if we see this, no, this is the handrail. The handrail is commonly seen when it is attached to a wall, no, and this is the stair rail. If it is attached to a baluster, no. This is a technical term that we use in construction. No? If we mean handrail, it is attached to a wall. If we mean stair rail, it's attached to a baluster. So these are the different types of newel posts. No? You can design or use. No? Okay, these are the different designs. No, this is a commonly used by interior designers, no? The different types of newel posts. But as architects, we have the responsibility to harmonize all of this design. No? So we need to make sure that the newel post is harmonizing with the total character of the whole building. No? So these are the balusters, no, and these are the hand railing. Okay. This is the hand railing, these are the balusters, and these are the scrolls. No, this is commonly located, no, at the end of a handrail or at the corner of a handrail, or even at the bend of a handrail. No, we put scrolls. So these are steel balusters. No, different designs of steel balusters. Okay, these are different design of stone balusters that we usually see at buildings that were made during the 1960s to the 1980s. No, they put stone balusters at the terrace, at the upper part of the building, no, or that lower part of the building, which is at the terrace. They put balusters. No, but now we don't commonly see these balusters. We only see the hollow blocks. We put hollow blocks or cladding for these areas. So we have the different types of materials that are used in stairs, no, and their benefits. We have the timber. Timber gives design flexibility. It is lightweight and easily to install. No, so this is the commonly used material in houses. No, the timber stairs. No, we also have the glass. gives an openness and clean airy feel to a room other than materials that just not provide. No? We also use stainless steel. No? It is used for handrails and balustrade. Steel is used also for handrails and balustrades, and it is also used for the fire exits. It can be seen on uh, steps, no, or different parts of the stairs, no. Another one is a stone, no. This is the most what you call this sturdy or most efficient type of material, which is the stone. So this is the staircase lighting, no. So this is another one that enhances the design of the stairs, no. You can put stair lighting, no, at different areas of the steps, no. Okay. These are the latest types of stairs that we see. No? No? This is the steps or the steps are hung, no, via metal, no, attached to the upper floor. No? This one, he used a glass as the balusters. No? This one, they use a what you call this metal wires, no, as balusters. Okay. So another one, this is another design. No, this is a winding stair. Okay. This is another type of stair design. This is a contemporary stair. No, this is commonly used on residentials. No, the contemporary mixture of different materials, but commonly used wood, and this one is they use carpet. No, in the other countries they use carpet as stairs. No, they use it on the stairs. No, so that it will lessen the accident. No, if you fall down, no, it will lessen the impact. No, okay. So another one is this is the curved stairs. No, these are curved stairs. This is the modern stairs. No? These are classic stairs. No? Classic. So as you can see, these are the samples that we discussed earlier. No? The first step, no? This is the rounded first step. So these are the traditional stairs. No? As you can see, the first step, no, they put designs on the first step. Okay, these are the commercial stairs, no, used on office buildings, schools. Okay, so this is the standard stride of an adult or on a horizontal plane, as you can see. No, the standard stride is about you need to imagine a safe distance of 2 meters from each person while they are walking on a what you call this, a flat surface, no, or a horizontal surface. The height of the handrail is about 90 centimeter, and the average step, no, of a person is about 62 centimeter, 62.5 centimeter. That is the average step of a person, no, or the average pace of the person while walking. So the ramp stride, no, is reduced proportionately. No, the desired slope of a ramp is about 1:10 or 1:8. No, that is the desired slope. No, that is 1:10 to 1:8. The optimum rise and tread ratio is about 17 to 29 over 29. So as you can see in so this is the ladder stair with the handrail. Okay, ladder stair. This is the normal stair. These are steps without a handrail. Okay, so as you can see in the figure, no, there is what you call a superimposed stair. As you can see, if you will put a stair above each other, no, you can save space. No, no, just like what we design on our buildings. No, we superimpose stairs above each, no, and you can see that the safe, no, headroom is about 2.1 meters, no. Okay. This one, as you can see, laying the rafters and beams parallel to the stairs saves spaces, no. This one, no. If you will create a attic, no, you can create the slope of your roof or the rafter, no, same as the angle of the steps. So you can achieve the 2.1 meter clearance, or the about uh, minimum of 2.2 meters. Okay. So this is the what you call this, the uh, uh, standard or the average, what you call this, uh, steps, no, the average line of walking line, no, on going up the stairs, no, which is about 55 to 45 centimeter. This is the allowing two people to go and up the stairs. You need to have a 125 centimeter or 1.2.5 meters. If there will be three people going up the stairs, you need about 1.875 meters, no. So 1.2 to 1.1 for two person, 1.875 for three persons. Okay, so these are the standards, no, width, no. Another one, okay, these are the minimum distance of dimension of stairs, no. You can refer to this one. This is the inclination of the ramp, no, of the stairs or ramp, no. So this is this you can refer on this table if you are doing designs, no. As you can see, ramps, this one is 1:6, one is to 2.5. Okay, if you put a stairs, this is about 17 to 29 degrees upon this one. This is about 21 to 20 degrees. This is about 45 degrees, this one, no. This is the steepest house stair, which is about 45 degrees. So this 30 degrees is the house stair, which is easily to climb. So this is 30 degrees, no. Okay. So these are the different types of stairs, no. We will discuss this will be discussed on the lecture number 2, the different types of stairs, no, different shapes of stairs. Okay. So these are the different profiles of steps, no. You can see. So you need to make sure that these are angled, no, so that there will be no impact on the riser, no. So you can see. So you need to make sure that, because of the tendency that the movement of the feet, no. If this is straight, no, it will this area will get frictions, no, or okay. So this is the handrail profiles, different types of handrails. This is the handrail or string details, no. All of these are now you can see all of this in your blackboard, in the blackboard, no? So these are the retractable stairs, no. So these are the space-saving telescopic stairs, usually used on attics, no. This is the fixed cut ladder. Okay, so these are the ramps. Okay, these are the spiral staircase. Okay,